I'm Nathan.
And Sumit. That's
And I'm DJ. What's good?
Okay. I'll be starting first with the part one of our project and our introduction. So we were looking at all these cars and stuff. Specifically the 2026 fuel economy data set. We're looking. Our response variable is CO2 emissions, rounded and adjusted to the value shown. As you can see, if you're watching the video, if you're a real subscriber, our qualitative predictors include engine displacement in liters, and the gas guzzlers miles per gallon, which is just, miles per gallon. But it only applies to some cars. It's only recorded for some vehicles. So for parts one and two, we are using a subset that only includes 373 of the observations that do have that metric. And then for part three, we have the entire set because we're not looking at it, so it doesn't matter. Uh, and that's the only variable that's limited at all. So our categorical predictors are drivetrain, stop-start system, and air aspiration method. Uh, Now we're going to look at our first plot, which is CO2 versus engine displacement. You can clearly see there is kind of a flat shape, but it flattens out at the end, so we suspected it might not continue that way. So we decided to go with looking at it in the quadratic way, as you can see there. We believe this is the best technique for the situation. Um, Now, when we're looking for miles per gallon, there's a very clear curve, very clear curve. So quadratic is the answer here. As you can see right there, there's our equation. Um, God, I've got a little bit of a headache. Um, so for our model utility test, for the first one, we found that we got an F score of 383.6 and a p-value that was next to nothing, 2.2 times 10 to the negative 16th. Um, Assuming an alpha of 0.05, we immediately reject the null, and we have statistically discernible evidence that displacement is useful for predicting combined CO2. Um, Now we're looking at the next variable. So the gas guzzler mile per gallon. Uh, we have a p-value of 3.94 times 10 to the negative fifth. Uh, since our alpha of again 0.05, we reject the null immediately again, and have statistically discernible evidence uh, that the relationship between engine displacement is not purely linear. And since we had a double check, we miles per gallon alone explains about 97% of the variation. For our response variable, it's kind of confirming the relationship that we originally saw. Now, lob up to Sumi.
yeah. So I am Sumit. I'll be explaining about how uh whether our two quantitative predictors interact, which is the miles per gallon and CO2. So if you see the part two scatter plot, the fitted lines have clearly different slopes. The miles per gallon effect on CO2 looks stronger in bigger engines compared to smaller engines. We fit the interaction model and tested the interaction term formally using the t-test. And the t-test statistic comes out to be a negative 11.68. And we get a p-value that is less than 2 times 10 to the power negative 16. Uh, Hence we reject the null. So we have discernible uh, evidence that to conclude that the interaction is real. So to explain it in plain English, we kind of calculated the partial slopes at two engine sizes. So for a 2 liter vehicle, each extra miles per gallon is associated with about 5.9 grams per mile drop in CO2. Um, for a 5 liter vehicle, the same 1 miles per gallon improvement is worth about 11.7 grams per mile. So the big engine kind of gets roughly twice the CO2 benefit per miles per gallon improvement as the small engine, which kind of actually makes sense because a 1 mile per gallon change matter more when you're going for say 15 to 16 compared to 45 to 46. So with that, I'm gonna pass it over to Damien.
All right, to finish it off, for part three, we use drivetrain and stop start as our categorical predictors. on the full 808 like scaled vehicle dataset, right? Now, the group means showed that the stop-start saving wasn't consistent across drivetrains, but most had lower CO2 with stop-start. However, the four-wheel drive group actually went the opposite way. So we suspected an interaction from the start. Now, our main effects model, that came back with a significant overall of F equals to 76.3. If you could scroll a little bit lower. There we go. 76.3 and a P less than 2 times 10 to negative 16. But when we tested interaction with the partial F test, we got F equals to 4.38 and a P value of 0.0016. So we reject our null. The effect of stop-start on CO2 genuinely depends on drivetrain, and our gut check from the raw means was right. So bottom line, engine size and miles per gallons are the dominant predictors. Both relationships are nonlinear, and both the quantitative and categorical predictor pairs interact with each other. So we believe a flat independent effects model would miss most of what's actually going on in this fleet. And that's all we have for you. Thank you. Subscribe, hit the like button, all that.